Welcome to Circuit Fix. Today I've got this boutique pedal made in the finest factory in China. So let's see what's going on with this thing. I've got a 1/4-inch cable plugged into an amplifier. And here's another 1/4-inch cable. The pedal doesn't come on. And it doesn't pass any audio. Let's disassemble this pedal and see if we can figure out what's going on with it. First I'll take all the knobs and nuts off the front. These are 10mm. I've got the one and only 10mm socket known to man. I'll enjoy it while it lasts. Let's see if I can get these pliers in this notch here and just turn this thing. Those are too big. There we go. Got that started. And one more here. Just flip this over to knock these washers off. They're all out of the way. And same thing with the side here. It's a little different size. And that is a 7/16. There are only 2 screws to take out of the original 4 that were probably here. And let's reveal what lurks underneath. Oh, it's a fine handmade design from the boutique factory in China. All right. Okay, I see some weirdness on the board already. Let's take a look under the microscope, do a visual inspection. Okay, we're under the microscope. Let's have a scan of the situation on the board here. And I think we found it already. There's a good bit of liquid damage on the top of this board. Right, that doesn't look very good. We've got a really crusty capacitor here. I don't know if that's shorted out or not, but we can definitely go in and find out. Got some more crust on this capacitor. That's probably some sort of transistor. It's got a little mess on it. And over here, got a little bit of liquid damage over here too. Corrosion. Oh. Yeah, same here. And along this coil. Since this pedal doesn't have power, it could be this voltage regulator, this LM358. And on these packages, it's pin 1 at the top left, 2, 3, 4, 5, 6, 7, 8 in that order. And if you look on the screen, you can see the pinouts. So let's buzz this out real quick and see if we can find any shorts. No short, no short. There's a short. So that's between pin 1 and pin 6. That's an input and the output shorted together. I don't think that's correct. But I can't be really for sure with that in the circuit, so I'm going to pop it off the board real quick. And let's test it off the circuit. Alright, it's melted. So no short out of circuit now. So I don't have a short out of circuit. Let's test the board to see if it still has a short. So the short's on the board. Maybe there's nothing wrong with the voltage regulator chip after all. So we'll put it back on. A little flux. That didn't really flow very well, did it? A little more flux. Huh. Not great, is it? It's coming in my little mini pen. All right, that's back on. It's kind of gnarly. Clean up our nasty flux. That was the Northridge fix flux, and it doesn't like getting very hot. It'll start burning. That's the original version, not the NF white that he's come out with since then. Now we need to do something about all this liquid damage up here. Let's try this. Let's put a bunch of flux on. Just come in and try to reflow it with the iron. If I use hot air on these capacitors, they're going to pop. I don't really want to take all this stuff apart. All of this. Come in with our toothbrush. See if I can get in here. And get all this liquid damage out. See if I have a better brush maybe to get in. Get a little skinnier brush here. I'll just take my electric air gun and blow this off. Now with this cleaned up a little bit better, I can kind of see, it looks like this cap here and this cap here have damage. So I'm going to try to pull them off the board here. Maybe I can get them with some hot tweezers. I don't think I want to try to use hot air next to that switch without removing the switch. I got it. And while we're over here, see if I can reach this one. Oh man, so tight. I think I got it. That's part of the cap that's broken off there on the pad. So we definitely have bad components here. Let me see if I can reach in there and maybe get that part off, clean that pad up. So tight. All right, I got it. Get rid of some of this glare maybe. That's a little better picture. All right, that's reading completely open. I don't know what this does in the circuit. But let's see if we can find a cap. I don't know what value it is. So we'll go with like an audio value of like, let's say 1 microfarad. All right. It's about the same size. There's our old one. Here's our new one. Let's see if we can get a reading on the new cap, just to sanity check our meter. Yep, that's reading 1 microfarad, exactly what it's supposed to be. And we'll check our old one more time. Yeah, no reading. Let's see if we can put this back on. Just kind of drag it over there maybe. This is so tight. See if I can get the whole thing hot. All right. Okay, I think I got that side. There. Yeah, I think we can call that on. All right, we got a little piece of something right there. Get that out. I'm going to guess that C41 is about a 1 microfarad cap. So let me find one of those in this size and drop that on. All right, this is a size 603 capacitor, and I'm going to guess it's probably about a 1 microfarad based on the reading of the one next to it. So let me see if I can get in there and put this little guy on. This will be a challenge. Oh. Get down there. Let me see if I can do like I did before, just kind of shuffle around the soldering iron, just kind of drag it over the pads and see if I can get it to stick. This is very difficult with the angles with all these parts around it. It's messy, but I think that's good enough. Come in with my brush. All right, I think that'll work. Let's see if this thing will power on now. Let's see if the thermal camera shows anything on the top. Nothing. Dead as a hammer. So pin 4 and pin 8 are power inputs. And there's nothing. There's millivolts on the meter here. Okay, let's test our battery clip first of all to make sure this is ground. And it is. Now I'll clip to the positive side. We can see right here there's a 9-volt test point. And I'm not getting continuity between the 9-volt pin on the battery and this. I wonder why. What about the center pin on the jack? And the 9-volt test point. It's like nothing is connected. Okay, so looks like we do have connection from our 9-volt battery positive side to this side of the diode. Let's check this diode. Open that way. Continuity that way. Let's just follow the DC. Good there. We have it here. This is a coil, I believe. We've got it there on this side. And nothing on that side. That's a coil, right? Maybe it's a busted coil. Now put some Kapton tape around these capacitors and that switch to try to protect it as much as I can from this heat. I'm going to come in with my hot air and try to remove this coil because I think it's open. All right. We got it off. I don't think we did too much damage. And here's our coil. We can test this just to see if that's our problem. This should pass DC voltage. It's just yeah, that's open. So here's our bad part. I think that corrosion from whatever that was that got in there has eaten this coil and destroyed it. Let me think about how to fix this. This is the other side of that inductor from the battery, and here's the 9-volt test point. Let's just see if we have continuity. And we do. So I think that's why it's not powering on, that coil. So this bad inductor is probably about a 470 microhenry. 471, it's 470. Closest thing I have is about that's closer to 50 microhenries there. But I'll put it on because why not? And it's a different package, different footprint, but it'll work. Just need to pass that battery voltage through. Let me get some fresh solder on these pads because I'm putting a through-hole component on it. The part that I'm coming in with is not what goes here. Let's see if I can get this to solder on good enough to behave. Got that lag. And get this to line up with that. Come with a little more solder, just blob that on. Okay. I think that'll hold nicely. Let's check back on the bench. Now let's see if we get continuity from our diode to our test point. And now we definitely have a reading across this inductor. Now that inductor has been replaced with something else, we should be able to get DC voltage down into the rest of the circuit now, because that's where the bottleneck was. I'm going to go ahead and plug a battery back in. No smoke. And to enable this to power on, we have to plug a cable in. And it lit up. Power switch works. Let's see if it passes signal now. It passes signal now. Yeah, it seems to work. All right, power's up. And it passes signal. That seems to have taken care of this problem, so I'll go ahead and clean this thing up, put it back together, and give it back to my buddy. Thanks for watching. We'll see you next time. Circuit fixed.